Hey guys, here's our homework following our Check Your Understanding. And again, here is our assignment. Now it looks like I'm giving you twice, but remember we're in a block schedule. So if I saw you guys every 45 minutes, the textbook suggests if I saw you every day, this would be what I would give you each day. Okay, so don't be too overwhelmed. You'll kind of get in a rhythm, get used to doing this many problems. You're just kind of ramping up to that. So hopefully that didn't throw anybody off. All right, so question number 1, 3, and 5, and 7, 9, and 11, and 13, 15, 19, 21, 25. Remembering the answers are in the back of the book, so you should be kind of writing out your answers, double checking the back of the book to make sure you know what you're doing. And if you notice here on the scanned items, I have included the answers so you can kind of look these up, okay? So now what you don't have is, you can see you only have the answers for the odd, so that doesn't help you with the multiple choice. So let's see what those were, C, D, C. And then just knowing the answers doesn't help you either. So C, D, C. Doesn't help you with the even ones I gave. You might notice that a lot of these questions look familiar because I give them on quizzes and tests, or I give the same question and change the number slightly. So you want to make sure you always know the multiple choice questions. So let's take a look. Okay. In order to show my work, I might need some space to write. So it looks like I didn't assign these problems, so I'll give myself a little bit of space to write there. And we didn't assign question number 32. So that gives us a little space to write. And again, if you need more space to write, you would maybe do all of these on a different piece of paper. So if I look at the first question here, it says, what is the interquartile range? Okay, so I'm actually going to jump to number 37. So it says, number 37 says, IQR, we know, is quarter 3 minus quarter 1, right? And that is at the 75th percentile. And this quarter 1 is at the 25th percentile. So this would be at the 25th, right? You see what I'm saying? And this would be at the 75th percentile. So, I don't have a perfect ruler here. You can see it's not perfect, but it looks like it's at about 5 and at about 2. So IQR, 5 minus 2 is 3. So that's how they got that number 3. But again, I would show your work here. And why is it important? Well, if you don't do the multiple choice to check your understanding, and you take the test or quiz and you do poorly, then it's obvious that, you didn't do this work to check your understanding, or you knew, but maybe you forgot. So if you ever want to retake a test, you have to go back and do these questions and go back over the video and, write out your work so that I'm just not regrading tests for the sake of regrading. Okay. All right, definitely 38. If the distribution of absences was displayed in a histogram, what would be the best description of shape? Ooh, this is very interesting. So I have to kind of think about this. I'm going to erase this just so I can see this. I'm noticing this is like tapering off, right? So let's see. My 5 number summary, I already kind of had that, right? 2. That'd be my median. I'm just going to call that like 3.5. And then that, let's say 5. And then my max, I'll say 14, and my min is 0. So if I put this on a number line, two, 4, 6, 8, 10, 12, 14. My whisker goes out to 0. The front of my box is here at 2. The middle of my box is at 3.5. Right, that's my median. And then my quarter 3 is at 5, so that's halfway between 4 and 6. And so I didn't make a histogram because that would take longer. But notice this whiskers going out. Oh, like my last quarter of data is really, really, really spread out. And so again, you can kind of see that this would be right skewed. So my box and whisker plot help me see that this shape would be right skewed. Meaning any of these values way up high, like this number 14, is even though the median's down here at 3.5, this number 14, just that number 14, would move the mean to the right. It would increase the mean. And skewed right means that the mean is to the right of the median. All right. Okay. So those are right off the cheater crat. We had that not this past class, but the previous class. So those are some good questions to practice those again. All right, let's look at 33 and 34. It says George's score on exam 1 in his stats class was at the 64th percentile. So if he's at the 64th percentile, that means the median is at the 50th percentile. And the third quartile is at the 75th percentile. So yeah, 64 is between 50 and 75. So definitely C makes sense. Question number 34. When Sam goes to a restaurant, he always tips the server $2 plus 10% of the cost of the meal. If Sam's distribution of meal cost has a meal of 9 and a standard deviation of 3, what are the mean and standard deviation of his tip distribution? So the mean, he says he always tips the server $2 plus 10%. So if on average he pays 9 and then he pays another 2 in tip, I feel like I could put that here. And then another 10% the cost of the meal, so that would be 90 cents. I'll just call that the bonus tip. So that means I'm paying, on average, for a typical meal, $11.90. It says, what are the mean and standard deviation of just the tip? So just the tip would be just this. So I need this and this. So those are trying to distract me, right? Then it says standard deviation. Well, notice in our notes, if you think back to our notes, the mean, the range doesn't change when we add. Therefore, the standard deviation doesn't change when we add. So he always tips $2. That's not going to affect his standard deviation, right? Because that's just adding. But this is multiplying. You take the cost of the meal. It's like, how did I get that 90 cents? I took the cost of the bill and I multiplied by 0.10. So when we multiply, we do affect the cost, right? So if it had a mean of $3 and his standard deviation, his meal deviated by $3, then I have to take his deviation, the $3, and multiply by 10%, which means I get the 30 cents. I'm not going to add 2 to the tip because I've already added 2 here, if that makes sense. When we add, in our notes, when we add or subtract, we change the mean, but not the standard deviation. When we multiply or divide, we change all 4. Or excuse me, I'll do both. We change the mean and we change the standard deviation. And we notice that in our question set today. Okay, the scores in the ACT entrance exam followed a bell shape with a mean of 21 and a standard deviation of. Okay, so a mean of 21 and a standard deviation of 5. So usually we write this. You haven't seen me write this yet. So we said a mean of 21 and a standard deviation of 5. Wayne's standard score in the ACT was negative. So we know he's here on this side. What was his actual score? Okay, so we talked about that a z-score is A minus P over S, AP statistics. Wayne's actual score, we don't know. We would predict for him to get a 21. That was a score that the average person got. And we know the standard deviation is 5. And now we actually know his z-score. So using some quick algebra, I can multiply both sides by 5. Right? And so his actual score would be, what is that, 18? And that's the score. So we need to show our work here because just circling our answer definitely doesn't do the trick. Okay, 36, I guess that's our last question. Question 36 says, George's bowling score is 180 and he bowls the league where the average of all bowlers is 150. So he's good. He's better than average. And the standard deviation is 20. So we list it like this, the mean and the standard deviation. So the mean is 150 and the standard deviation is 20. Now in the second set, Bill, his mean and standard deviation is different. The mean in his league and his score is good for his league as well, but without the z-score, we can't compare an apple and an orange. Here we can. So is George good for his league? Yeah. And is Bill good for his league? Yeah. But which one is better relative to their league? That's what we can do with z-score. All right, so we got 15 here. So let's use their z-scores to figure out who's better. So in the blue one, the z-score would be his actual, George's actual was 180, minus predicted, 150 over 20. And then Bill, so this is George, and then Bill, so what is that, 30 divided by 20. And the z-score of Bill, he's 190. Where a typical score is 160 out of 15. Ooh, okay. So this is definitely better. Meaning if we had a curve of both of them, they have different middles and different widths as we go to the left and the right. But it looks like Bill is further to the right, right? And George is definitely to the right as well, but he's only 1.5 standard deviations from the mean. So who is better? For sure, Bill. Bill, because his 190 is higher? No. Yes, Bill, but just the fact that his raw score is higher doesn't mean that he's better. Bill, because his standardized score is higher. Okay, yes, we like that. I'm going to keep reading, though. Bill and George have the same rank. No, not the same rank. George, because his standardized score is higher. No, George's standardized score, that's false. George's standardized score is 1.5 versus 2. Last, George, because his standard deviation is higher. No. In fact, the standard deviation could help or hurt him depending on, if the league is more variable, that could change things for him. Notice both calculations had different standard deviations. All right, so Bill it is. There are those multiple choice questions. Thanks for joining us. Have a good